How do you take the derivative of an inverse function? Let's take a look at this example. Before I start actually doing this problem, what I want to do is just look at the idea. What do we know about an inverse? Let's say this is here some function. An inverse is going to be a reflection about the line y equals x. So it's looking something like that. If I want to find the derivative here of the inverse of this function at a given some point, if a comma f of a is on the graph, then f of a comma a is on the graph of the inverse. What can you say about this line, tangent line, versus this tangent line? Well, the key is understanding the relationship between the function and its inverse. So when I have xy on the function, it's switched to yx on the inverse. So what's going to happen here is, here's some tangent line. I would find the slope is delta y over delta x. And on this one, it's going to be that same idea, but what is delta y? And delta, what happened compared to our original one, it is the reciprocal of it. And so this is going to be 1 over m. So if I know this tangent slope, then the reciprocal is going to be this, the derivative of the inverse. Since we're talking the slope of the tangent line is the derivative. So now let's apply that. We're going to look at that. That's what the understanding is conceptually. And I'm going to use, and this is the way I'd want you to do this, f of g of x. If we have two functions that are inverse, f of g of x has to always equal x for all x in the domain of g. Now let's go ahead and take the derivative of both sides of this. And we're going to say f and g are inverse functions. So the derivative of the left side would be f prime, the derivative of the outside, evaluated at the inside, times the derivative of the inside. And then on the right side, we get 1. So we get g prime of x equals 1 over f prime of g of x. So now let's see. What we want to do is, in this situation, we want to find g prime of 5. So we want to say 1 over f prime of g of 5. Now the question becomes, can we find g of 5? Well, when we're looking at that, if we're saying g of 5, that means on our inverse function we have 5. And we want to say, what's that y value? But for the function itself, that means the y value was 5. What's the x value? Well, it's possible even if we weren't given this, we could find this by inspection, just by looking and thinking, okay, we can get 5 by 1 plus 4, so x is 1, but we were given this point anyways. This is 1, so that means when x equals 5, g equals 1, so we're looking at 1 over f prime of 1. And what is f prime? F prime would be 5x to the 4th plus 4. So f prime of 1 is 9. And this slope is 1 over 9. So let's take a look. That would be like saying this slope here is 9. And so the slope of the inverse at the 5 value would be 1 over 9. I want you to go through these algebraic steps here, but also be thinking about it, and this can help to see, as a check, is to see what you're doing is correct.